Okay, here we will look at the 2017 paper 1 for maths grade 10. Okay, first question says, given that q is equal to b squared minus 4ac all square rooted, determine the value of q if a equals 2 and b equals minus 1 and c equals minus 4, and they're asking us to leave the answer in the simplest third form. Okay, so the way to do that is to just take this same equation that they gave us and substitute in the values that we have. So in place of b, we'll have minus 1 squared, minus 4, and then in place of a, we'll have 2, and in place of c, we'll have minus 4. Okay, and then we'll just plug that into the calculator. Okay, and that gives us root of 33. Okay, so that's the answer for that there. I'll put all the final answers in blue. Okay, next question is, state whether q is rational or irrational. Now remember, rational numbers are numbers that can be expressed in a fraction form, so in the form of a over b, whereas irrational numbers can't be expressed that way. There's no pattern. So if we take root of 33, 33 isn't a perfect square, so that means that we aren't going to get a rational number, so that means that q is irrational. Okay, between which two consecutive integers does q lie? So now you take root of 33, you put it into your calculator, and you see what the value is. So root of 33, if you put it into your calculator, you'll get 5.744, and then it goes on. Right, that's another way to see that this was irrational, because the calculator spat it out, and not in a fraction form. But anyway, so the two consecutive integers that it lies between is obviously 5 and 6. Okay. The next 1.2, factorize the following expressions fully. Okay, so let's see how we're going to do that there. Now, if we look at this here, it on the surface looks like we can't really factorize anything, but that's not true. Let's see how we can change things around to make it factorizable. So if I take this here, t squared r minus s, and I manipulate this in a specific way. So let's do this by taking out negative 1. Okay, let's multiply negative 1 by this here. So obviously we'll have r and minus s, right? Let's see if that makes sense. If we multiply minus 1 into there, I'll get minus r, and then if I multiply minus 1 by my minus s, I'll get plus s, and you can see that's the same as that, so that means that that's fine. Okay, so now that we have that written like that, you can see that we have a common factor. R minus s is common, so we can further factorize that now by taking out that r minus s. So we'll get that, and then t squared minus 1. Okay, now if we look further though, if we look at t squared minus 1, we can still factorize that further, because remember, difference of two squares. T squared is a square, of course, and 1 is a perfect square as well, because 1 squared is 1. So I can write that as r minus s, and then t minus 1, t plus 1. Okay, because remember, for difference of two squares, let's say I have, for example, a squared minus b squared. That would become a plus b, a minus b. So you can see there we did the same thing with t minus 1. Okay, and then that's the final answer here. Okay, cool. The next question, 1.2.2. Let's bring it down here and look at it. So we have x cubed plus 1 over x squared minus x plus 1. Okay, now remember for cubes, if you're adding two cubes, so x cubed again is obviously a cube, and plus 1 is obviously a cube as well, because 1 cubed is 1. Okay, we can simplify that there. So we start off by taking the two things and adding them, so x plus 1, and you multiply that by x squared minus x plus 1. Okay, so the general form of that would be, let's say I have a cubed plus b cubed. It would be a plus b multiplied by a squared minus a minus ab plus b squared. Okay. Okay, so that's the general form of that, and then we applied it to this here. Now, if we take that there and divide it by our original x squared minus x plus 1, you can see now that we have some common things there, so we can cancel that out, right? And then we end up with x plus 1 as the final answer. Okay, I've just moved onto this blank document here for question 1.3 because it's going to be a bit longer, but anyway. Okay, 1.3.1, simplify the following completely. Okay, so how are we going to do that there? Well, from the looks of it, looks like we're just going to have to multiply these two brackets by each other. So let's start there. 2y plus 3 multiplied by 7y squared minus 6y minus 8. Okay, so how do we multiply a binomial by a trinomial? Okay, so the way to do that is to start with, let's say we start with 2y. So we start with that term. We first multiply it by the first term there, then the second, then the third, and then we're done with that term. Okay, and then we move on to the second term now. So we take this plus 3, and then we do the exact same thing. So we multiply it by each term of the trinomial. Okay, so let's start with that. Let's say 2y times 7y squared, and I'm just going to show every step, but you don't have to actually do this. You could just write the final answer, but anyway, and then plus 2y times minus 6y plus 2y times minus 8. Okay, so that's the 2y taken care of, so there's it there. You can see we multiplied it by each term in that one, in the trinomial, and then now we can multiply plus 3 by everything. So plus 3 times 7y squared plus 3 times minus 6y plus 3 times minus 8. Okay, and just to show you, there's the plus 3's again. Okay, so now we'll just simplify that there. So 2y times 7y squared is of course 14y cubed minus 12y squared minus 16y plus 21y squared. I'm just multiplying all of these together, so then minus 18y and minus 24. Okay, and then now we just group like terms and add or subtract. Okay, so what do I mean by a like term? I mean that they have the same variable. So if you look here, we have y cubed. Okay, let's see if we have any other y cubes. We don't. Okay, so that means we can just write 14y cubed. Okay, let's move on to y squared. Look, we have that as well. So we'll add those two together. So minus 12 plus 21. and it gives us 9. Okay, so you can see we just took those two because they were like terms, they had the same variable, this y squared, and then we added them together. Okay, so now let's move on to y. So here we have minus 16y and minus 18y, and if we add those together we get minus 34y. Okay, and now the constant, which has no variable, is just minus 24. Okay, so there's the final answer, 14y cubed plus 9y squared minus 34y minus 24. Okay, cool. Let's go to 1.3.2. So we have 3 over x squared minus 9 plus 2 times x minus 3 squared. Let's see if that's right. Okay. So let's start with this one here. So if you look at, now the trick with these questions is to see how we can simplify everything in here. So if we look at those two denominators, we can see that there's some simplifications that we can do. So if we start with this one here, we have x squared minus 9. That looks like difference of two squares, right? Because 9 is a perfect square, it's 3 squared, and x squared is obviously x squared. So we have x minus 3, x plus 3. Okay, and then on this side we have x minus 3, x minus 3. Okay, I mean, we can just leave it as x minus 3 squared, or we can do it like that, doesn't really matter. I think it'll just be easier if we leave it as x minus 3 squared, actually. Okay, now how do we work around this here? So if you look at this, we have they don't have the common denominator, so we can't just simply add 3 plus 2 and then put some denominator there. We actually need to do some manipulation. So the way to do this is you start with the first one, right? So you start with 3 and you multiply it by the other term's denominator. Okay, so here we'll have 3 times x minus 3 squared. Okay, and then you do the same thing for the other one. So you say plus 2 and then you multiply it by x minus 3, x plus 3. Okay, and then for the denominator you just take both of these and you multiply them together. So you'll have x minus 3, now it'll be cubed, because see, we're taking this 1, multiplying it by x minus 3 squared. So you get x minus 3 cubed times x plus 3. Okay, if you look closely at the numerator, you'll see that we have a common factor. So x minus 3 is there, x minus 3 is there as well. Yeah, obviously it's squared, but that's fine. So we can factor out that there. So let's say x minus 3, and now we're factoring it out. So we'll have 3 x minus 3. Do you see how it's no more squared here? Because it needs to be multiplied there out. Okay, and then plus 2 times x plus 3. So we've now extracted that x minus 3 on each of those. Okay, close that bracket, and then we have x minus 3 cubed x plus 3. Now if you look closely here again, you'll see that we have x minus 3 and x minus 3 here. And because we have two things that have been multiplied together in the numerator, and same thing for the denominator, we can just cancel out any common terms. So x minus 3 is common there and it's common here. So this will go from cubed to squared. Okay, so let's just neaten that up. We can get rid of this and this will become squared now. Okay, cool. Now let's go back to the top. I'm just going to move this down so we get some space. Okay, now if we go back to the the numerator here, we can just multiply out everything in the brackets there to simplify it. So we'll have 3x minus 9 plus 2x plus 6 all over x minus 3 squared x plus 3. Okay, and now we can again group like terms. So we have 3x squared plus 2x, 3x plus 2x, so we'll have 5x we'll have 5x, and then minus 9 plus 6 gives us minus 3. Okay, and then the bottom nothing changed, so we still have x minus 3 squared x plus 3. Okay, and that is the final answer. Okay, let's move on to 1.3.3. So I'm just going to copy that down. 1.3.3, we have 3t minus 3 to the power of t minus 2 all over 2 times 3t minus 3 to the power of t. Okay, let's see how we can manipulate this here. So the first thing to do with questions like this is to identify ones that have these more complex exponents. Okay, so you can see there we have 2 terms in the exponent instead of 1. So let's write that first one down like normal, but then for the second one we can now break this apart. So instead of writing 3 to the power of t minus 2, we'll have 3 to the power of t multiplied by 3 to the power of minus 2. Okay, because if you remember your exponent laws, let's say I have a to the power of m times a to the power of n. That's the same as me saying a to the power of m plus n. Okay, so if you look back here, if we have to convert this here, I have a common base of 3, and then I'm adding my exponent, so it'll be t minus 2. And if you look there, that's exactly what we have up there, so that means that's fine. Okay, let's simplify the bottom one now. So we'll, well, there isn't much to do at the bottom, although what we can notice is that we have a common term. So you can see that in each of those, we're multiplying each term by 3t. So let's factor that out. So we'll have 3t, and then we have here 2 minus 1. Okay. Let's look at the top again now. So here again we have a common term of 3t. So let's factor that out. So we'll have 3 to the power of t, 1 minus 3 to the power minus 2. Okay. Now how do we express 3 to the power of minus 2? Well, let's think about our other exponent laws. Let's say I have a to the power minus m, right? That's the same as me saying 1 over a to the m. Okay, so for here, I can rewrite this as 1 over 3 squared, right? Because we're taking away that negative sign. And 3 squared is the same as 9. Okay, so just to clarify, I took 3 to the minus 2. I made it 1 over 3 squared. And then that's the same as saying 1 over 9, because 3 squared is 9. Okay, and then at the bottom we still had 3t. 2 minus 1 is just 1, so I don't even need to show that because it's the same thing. And then now we have 3 to the t on the top and the bottom, so we can get rid of that. And then we just have 1 minus 1 over 9, and that comes to 8 over 9 as the final answer if you subtract that 1 minus 1 over 9. Okay, cool. So that's basically question 1 done. Okay, let's look at question 2. Again, I've moved it to a separate document. Okay, given 4 minus 2x is less than 16, where x is a rational number, solve the inequality. Okay, so 4 minus 2x is less than 16. Okay, so how do we solve inequalities? Well, it's honestly much like solving normal equations. You start by trying to isolate the term or the variable. Okay, so in this case, it's going to be minus 2x. So to do that, we'll bring 4 to the other side and then subtract it. So we'll have minus 2x is less than 12. Okay, because 16 minus 4. And then now we can just divide both sides by minus 2. Okay, so we'll have x, and then on this side we'll have minus 6. Now here's where the catch comes in. So whenever you have an inequality and you're dividing by a negative, so here we divided by negative 2, the sign switches around. Okay, so now instead of being less than, it will be greater than. So there's your answer there. X is greater than minus 6. And then to test this here, you can substitute in that minus 6 into that there. So if I say 4 in my calculator, 4 minus 2 times minus 6, you'll see I get 16, right? So that means that in order for this expression to be true, right, in order for 4 minus 2x to be less than 16, I need my x to be greater than minus 6. So now instead of saying in your calculator now again, instead of saying 4 minus 2 times minus 6, let's try something greater than minus 6. Let's try minus 5. And you see if I do that there, I get 14. And 14 is in fact less than 16. So that means our answer is correct. Okay. The next question says, represent your answer to question 2.1.1 on a number line. Okay, so let's say I have a number line here going like that, and let's say at some point I have 0. So obviously minus 6 is going to be on the left of that, so we have minus 6, and we want x to be greater than minus 6, so x has to go that way. Okay, and since it's not inclusive, you can see that it's just x has to be greater than minus 6, not greater than or equal to. We leave the dot uncolored. So for this question, this would be the right answer, like this, right? But let's just say hypothetically that the answer was that, then we would color the dot in. Okay, but it's not, so we'll just leave it uncolored, and then that's the answer for that. Okay, the next one is 2.2, so simultaneous equations. So our two equations are minus 2x minus y equals 10, minus 2x minus y equals 10, and 3x minus 4y, 3x minus 4y equals to minus 4. Okay, so how do we solve simultaneous equations? Well, the easiest way to do it is to firstly isolate one of the variables. So if we look at both of our equations, let's look at the coefficient of each of our variables. Okay, remember we have two equations, so that means we have two unknowns. The two unknowns are x and y. Okay, so now let's pay attention to the coefficients on each of those variables. So we have minus 2 for s, we have minus 1 for that y, we have 3, and we have minus 4. Okay, so just looking at that there, it looks like the easiest one to isolate would obviously be this one here, because there's no number multiplying it there, it's just a negative 1. Okay, so let's see how we can isolate that there. So let's bring y to this side here. Okay, so now it will become positive, and let's bring 10 to that side. So now we'll have minus 2x minus 10 equals y. Okay, so let's call this our equation number 1, and let's call this equation number 2. So now we tell the examiner that we're going to sub equation number 1 into equation number 2. Okay, so we have 3x. I'm writing down this equation here. 3x minus 4, and now in place of y, we put in our equation number 1. Okay, so minus 4 times minus 2x minus 10 equals to minus 4. Okay, and let's solve for that now. So it's 3x plus 8x plus 40 equals to minus 4. Okay, let's group our like terms. So we'll have 11x, and then I'll bring this to the other side. So we'll have minus 44 on that side. Okay, we'll divide both sides by 11, and then we'll get x is equal to minus 4. Okay, so now we can call this equation number 3. Okay, and then I'll come here, I'll just split this in half, and then say sub equation number 3 into equation number 2. Okay, so 3, and now again in place of x, I'm going to substitute in minus 4. Okay, so 3 times minus 4 minus 4y equals to minus 4. Okay, and so with that I'll get oh, and by the way, you can substitute this this equation number 3 into either of the equations. It doesn't matter. I think it would have actually been easier to go into that one, but it doesn't matter now. We'll just carry on. So we'll have minus 12 minus 4 equals to minus 4y here. Okay, again we'll group like terms, so I'll bring this minus 12 to that side, so I'll have minus 4y equals to minus 4 plus 12, which is 8, and then I'll divide both sides by minus 4, so I'll get y is equal to minus 2. Okay, so there's your final answers. X is equal to minus 4, and y is equal to minus 2. Now to test this here, I'll leave this up to you, I won't do it, but you can take these values that we have and substitute them into these original equations and see if you get the right answer. So for here you'll say minus 2 times minus 4 minus minus 2, and that should give you 10. And for the other one you do the same thing, you sub in x and you sub in y, and it should give you minus 4. And that's how you test if you got the correct answer. Okay, let's move on to question 2.3. So it says solve for x, and then we're given that equation x times x minus 5 over 6. So let me just write that down. X times x minus 5 over 6 is equal to minus 1 is equal to 0. Okay, so it's minus 1 is equal to 0. Okay, cool. So the first thing I want to do is I want to get rid of this denominator, this fraction. Okay, so the way to do that there is you multiply every single term by the denominator. Okay, so let's start here, x minus 5. Now think about this here. Let's say I start off with x times x minus 5 over 6. If I multiplied that by 6, all I would do is get rid of the denominator. That's why I just wrote down the numerator as the answer. Okay, and if I take 6 multiplied by minus 1, I get minus 6, and then obviously anything times 0 is just 0, so I'll have 0 there. Okay, and now you can see I'm going to end up with a quadratic equation because I'm getting squares here. So let's say x squared minus 5x minus 6 equals to 0. Okay, now we have a trinomial. So how do we factorize a trinomial? Well, we need to find our common factors. Okay, so the best way to do that there is to find a number, two factors of 6, or when you multiply these two together, in this case it's just going to be 6 minus 6, that when you multiply them you get that, and when you subtract them or when you add them you get the middle term. Okay, so in this case our two numbers are going to be minus 6 and plus 1. Okay, so if you think about that there, we selected minus 6 and we had plus 1. Okay, so if I add these two together, I'll get minus 5, which is my middle term. And if I multiply them, I'll get minus 6, which is my last term. Okay, so that's the two factors that I'll use, and I'll just break it up like that. Okay, so let's start with, now we're going to isolate these two terms. So we'll start with these two, and then we'll move on to these two afterwards. So let's start with the red ones here. X is the common factor. We have x minus 6. And then on this side, we have no common factors. So we'll just factor out 1. Okay? So you see that if I multiply that there, I'm going to get x minus 6 again. Okay? And that's equal to 0. And now you can see that we have common factors, which is x minus 6. So I can factor that out. X minus 6 and x plus 1 equals 0. Okay? Now, obviously we're going to equate each of these to 0, and the reason we do that there is because, remember, we're trying to get this whole thing, or this side at least, has to equal to 0. Okay, and how, if you think about multiplying two numbers, right, let's say I have two numbers, a times b equals 0. Okay, the only way for me to get two numbers to multiply and equal to 0 is if one or both of these numbers are equal to 0 already. Okay, so let's think about that. Let's say I have 5 times 0, that gives us 0. Or let's say I had 0 times 5, that gives us 0. So you see, one of them has to be equal to 0, or both of them have to equal to 0. And then that's the only way to get something, two numbers to multiply and give us 0. So that's why we say that either x minus 6 equals to 0, or x plus 1 equals to 0. Okay, so let's now solve for that there. So this is pretty straightforward. We're just going to have x equals to 6, or x is equal to minus 1. Okay, now again, to test if your answers are correct, you're going to take each one. So let's start with x equals 6, and then you're going to come to your original equation, and you're going to insert 6 in wherever there's x. You're going to substitute it in, and you're going to do it for this side here. And if your answer comes to 0, you're going to put all that in your calculator. If your answer comes to 0, then you know that you have the correct answer. And you do the same thing for x equals minus 1. Okay, I'll leave that up to you again. Alright, the next one says, we're looking at this one now, that solve for x if c equals to the root of a plus 2x. So 2.3.2, this was 2.3.1. So c equals to the root of a plus 2x. C equals to the root of a plus 2x. And we're trying to solve for x. So that means we're going to make x the subject of this equation. Okay, so the first thing to get rid of here, because remember the goal here is to isolate x on its own. So the first thing to get rid of would be the square root. Right, now, how do you get rid of the square root? Well, you do the opposite of it. So let's say, for example, I have the root of a. If I want to get a alone, I just need to square a. I need to square the square root of a, right? And then I'll get a. So let's square both sides. So I'll have c squared equals to, now remember, if I square that there, I'll just get rid of the square root. So I'll have a plus 2x. Okay. And now again, we want to get x on its own. So I'll bring this to the other side. So I'll have c squared minus a equals to 2x. And then I'll divide it both by 2 to get x on its own. So c squared minus a over 2 equals x. Okay, and that's the answer. Okay, cool. Let's look at now question 2.4. So it says, Tabello is currently 4 times as old as his daughter Linda. 6 years from now, Tabello will be 3 times as old as Linda. Calculate Linda's age currently. So this sounds like a very complicated thing, but in reality it's just asking you to convert these words into some mathematical equation. Okay, so let's think about this here. Let's call Tabello's age T. Okay, and let's call Linda's age L. And remember, you can pick any letters you want to. You can say X and Y, P and Q, or whatever. I'm just using T and L because that's their initials. Okay, so Tabello is currently 4 times as old as Linda. So T equals to 4L. Okay, so that's our first hint, right? And then the next one says 6 years from now. So you take in T's age and you're adding 6, because in 6 years from now he'll be 3 times as old as Linda. So T plus 6 equals to 3L. Okay, and again this is 3L plus 6 because she's also gotten 6 years older. Okay, so now you can see that we have 2 equations again, and this looks like simultaneous equations, right? Because we have 2 unknowns and we have 2 equations. So I'm just going to rewrite those 2 equations down here. So this is question 2.4. So again, I had T is equal to 4L, and I had T plus 6 equals to 3 times L plus 6. So I'm going to read this question again. Okay, so let's see. So now we already have T as the subject of this equation. So all you have to do is substitute it in there, right? So in place of T, I'm going to put in 4L. So I'll have 4L plus 6 equals to 3L plus 18. Okay, and then I can now group my like terms and solve for L. So again, I just moved 3L to that side, and I moved 6 to that side and made it negative. So 18 minus 6 is 12. So that means, therefore, Linda is currently... Okay, let's look at question 3 now. So question 3 is number patterns. So 3.1, consider linear sequence 5, 8, 11, B, 17. Write down the value of B. So that's pretty straightforward. Let's see what the pattern is. So you can see from 5 to 8, I added 3. Same thing from 8 to 11. So that means to get to B, I'll have to add 3. Okay, so 11 plus 3 is 14. Okay, so that's the value of B. Let's say B equals to 14. Okay, 3.1.2. Determine the nth term of the sequence. Okay, so remember for linear sequences, we have Tn is equal to, and then the coefficient of n will be whatever the difference is. So in this case, it's going to be 3n. Okay, and now you just test it out. Okay, so let's start with 3 times 1 is 1. So then to get to 5, we have to add 2. Okay, so let's see if this works. Let's see for the next one. 3 times 2 is 6, and then plus 2 is 8. 3 times 3 is 9, plus 2 is 11. So that means our formula is working. So this answer is correct. Okay, you should always test your answers to make sure that they are correct. Okay, 3.1.3. Calculate the value of the 15th term. So now that we confirm that our formula is right, we can just substitute in 15. So now in place of n, we're just going to input 15. Okay, so T15 is equal to 47. Okay, because that's 45 plus 2 is 47. Okay, 3.1.4 now. So this answer is correct as well. Which term in the sequence is equal to 83? So now if you look at this formula we have, essentially at any point in time we have 2 unknowns. So you have the value of the term and also which term it is. Okay, so in 3.1.3 we were given the n value, and our goal is to solve for the tn value, right? T15, that's what we're trying to get to. Now in this case it's inverted. We're given what the answer is, so let's start here with this thing, 3n plus 2. We're given what tn was equal to. It was equal to 83, and our goal is to solve for n because it says which term. Okay, so then we can just bring that minus 2 to that side, so 83 minus 2 is 81, and then 81 divided by 3 is 27. Okay, and then that answer is correct as well. Okay, let's move on to 3.2.1. Okay, so here we're given a pyramid looking thing with numbers, and it says consider a number pattern below created by using the numbers of the sequence 2, 6, 10, 14, 18. So 2, 6, 10, 14, 18, and so on. Okay, and you can see that they added 4 to each previous term to get the next one. Okay, let's see if that's going to help us to solve the answer. Calculate the sum of the rows of the numbers in the 8th row. Okay, so how are we going to do that there? Let's start by seeing if there's some pattern to the sums of each row. Okay, so I'm just gonna do this like this, and then we can see if there's a sum, a pattern. Okay, so the sum of the first row is just 2, right? There's only one number. For the next one, 6 plus 10, 16. And then if we add all of these together, let's see, 14 plus 18 plus 22 gives us 54. And then 26 plus 30 plus 34 plus 38 gives us 128. Okay. Now here is something that you can notice from here. Okay. So if we look at the first, let's call this row 1. So row 1, 2, 3, 4. Okay. If we look at this here, right? If I look at row 1, I took this n number, right? So whichever row it was, I multiplied it by 2 and I cubed it. Okay. So if I take 2 times 1, if I take 1 cubed, it's 1, right? And then 2 times 1 is just 2. If I look at the next one in the line, I have 16. Okay. So 2 cubed, because 2 is n, right? It's the second row. 2 cubed is 8. And if I times that by 2, I get 16 as well. So here I had 2 times 1 cubed. Now here, on this one here, let's see what 3 cubed. 3 cubed is 27. Okay. And then 27 times 2 is 54. So it's 2 times 3 cubed. Okay. Here as well, 4 cubed is 64, and then times 2 is 128. So it's the same as saying 2 times 4 cubed. Okay, now what do you notice? That these numbers here are the same as the row number. Okay, so we essentially got a pattern where we have 2n cubed. Okay, where n is the row number. Okay, so you can show that there now. You could say row 1, the sum, let's say sum of row 1 equals to 2, sum of row 2 equals to 16, and so forth. And then you could show the pattern is that, right? And now all you have to do, because they asked for the 8th row, is to just do 2 times 8 cubed, which gives us 1024. Okay, cool. Okay, determine the mean of the numbers in the 20th row. Okay, so let's try and see if we can come up with something similar for this one here. Let's see if we can find a pattern for this one as well. Well, there isn't a pattern to find, because let's think about this, right? What is mean? Mean is the average, right? So it's essentially you're taking all of the values, adding them together, right? This is mean. So you're taking all of the values, adding them together and dividing it by the number of values in that row, right? So, okay, let's keep that there so I can explain something. If you look at this here now, to get the mean, we need the sum of the row and also the number of numbers in that row. So we know how to get this here, right? That's what we did in 3.2.1. We found this equation. Okay, so we'll be able to find the sum. What about the number of numbers in each row? Well, if you look at it, it just goes up by the row number. So row 1 has 1 number, row 2 has 2, 3 has 3, 4 has 4, and so on. Okay, so let's look at this now. 3.2.2. So mean is equal to the sum over the number of numbers. Okay, so the sum of row 20, because that's what they're looking for, is just going to be our equation here that we found, but instead of n we'll have 20, so that, and number of numbers, like I said before, is just 20 because it goes up by each row number. Okay, now we can plug that into a calculator and we get 800 as the answer. Okay, let's look at question 4 now, which is finance. Okay, question 4.1 says, 7 years ago, Mrs. Gray decided to invest 18,000 Rand in a bank account that paid simple interest at 4.5% per annum. Calculate how much interest Mrs. Gray has earned over the 7 years. Okay, so remember we have this formula here that says that the amount is equal to the principal multiplied by 1 plus IN, right? Where I is the interest rate and N is the amount of time. Okay, so and remember amount is like, if she put this into a bank account, it's basically how much money is in the bank account now, not how much interest she's earned. Okay, it's the total amount. Okay, the principal amount here was 18,000 Rand, if I'm not mistaken, yep. And it's at a rate of 4.5% and it's 7 years. Okay, so 1 plus, and now 4.5% is the same as saying 0.045, right? So 0.045 times 7 years. Okay, now we plug this whole thing into the calculator. So 18,000 times 1 plus 0.045 times 7, and that gives us 23,670 rands, right? But now remember what I said, this term A here is the total amount in the bank account, but the question specifically asked for how much interest she's earned. Okay, so obviously this is the total amount. The interest is whatever is on top of the original amount. So the interest would equal to 23,670 minus 18,000, because this is how much she started with, and this is how much she ended with. So the interest is the difference between those two. Okay, so you can just do 23,670 minus 18,000, and that gives you 5,670 Rand. Okay, and that's the right answer there. Okay, let's move on to 4.1.2. Mrs. Gray wants to buy a television set that costs 27,660 Rand. If the average rate of inflation over the last 5 years was 6.7% per annum, calculate the cost of the television set 5 years ago. Okay, so you can think about inflation as if it was interest. Okay, but it's increasing like compound interest almost. Okay, so you can think about it like that. So you can use the same equation that we use for compound interest. So A is equal to P1 plus I to the power of n. Okay, so in this case here, A is equal to the amount that it's currently worth, right? P will be the amount that it was originally worth. I again is the inflation rate, and n is the number of years, the time. So it's currently worth 27,660. There's an interest rate of 6.7%, and it was 5 years. Okay, so let's put all that information in. So it's 27,660 equals to, and remember we're solving for P now, 1 plus 6.7, so 0.067 to the power of 5. Okay, so now you can put this whole thing into the calculator. You'll get an answer, and then you'll take that answer, you say 27,660 divide by that answer. Okay, so let's do that there now. So 1 plus 0.067 to the power of 5 will give us an answer. Now I'm going to take 27,660 and divide it by that answer, and then you'll see that P is equal to 20,000 rands. Okay, because I think it's yeah, I mean it's 0.00382, but you can just put it as 20,000. Okay. Okay, so yeah, I'm just gonna leave this as 20,000 then, and that is the correct answer. Okay, 4.1.3 now. At what rate of simple interest should Mrs. Gray have invested her money 7 years ago if she intends buying the television set now using only her original investment of 18,000 and the interest earned over the last 7 years? Okay, so let's start again with our formula. Okay, so remember, this is how much money is in the bank account. This is how much you started with. That's your interest rate, and that's how much time. Okay, so let's think about this now. We know the amount that we need to have at the end because they're saying that she wants to buy the television set. So that means the amount that she needs is 27,660. Okay, 27,660. Okay, we know the principal amount as well. It's 18,000. Okay, let's read the question again. She wants to buy this year, when she's saving up for it for 7 years. Okay, so we know the time is fixed as well. So the only unknown here is the interest rate, and that's what we're going to be solving for now. Okay, so that's 7 times I. Just make that neat. Okay, and remember we're solving for I. So again, I'll just take this, divide it by this. So 27,660 divided by 18,000. That gives us an answer. Then I can subtract 1 from that and divide that by 7. Okay, and then the interest rate that I get is 0.077, let's say. Okay, so that's the same as 7.7%. Okay, so we're now on question 5, which is functions. So the diagram shows the graphs of g of x, which is equal to ax squared plus q, and f of x, which is equal to mx plus c. R and S, so R and S, S has those coordinates 2 and 0, are the x-intercepts of g, and t, 0 and 8, is the y-intercept of g. Graph F passes through R and T. Okay, write down the range of G. Okay, so first question is, what is range? Range is the y values, essentially what's the extent of the y values. So if you look at G, which is our parabola here, if you look at it, you can see that it goes down for infinity, right? But it has a very a cap here of how high it can go. Okay, so what's that upper limit? Well, it's 8, right? So that means that our y values are less than or equal to 8, because they can go down forever, but they can't go higher than 8, but they can equal to 8. So it's less than or equal to 8. Okay. Okay. Write down the x coordinate of R. Okay. So something to keep in mind with parabolas is that the turning point here, the x value of it, will be the exact midpoint of the x values between the two x-intercepts. Okay. So if you look at it, we started at 0, we moved 2 units in this direction to get 2. So obviously we have to move 2 units again to this one, so it will be minus 2 because it's in the opposite direction. So it's minus 2. Okay. And obviously that's 0, the y value is 0. They didn't ask for that, but anyway. Calculate the values of A and Q. So A and Q are here in the parabola. Okay, now how are we going to do that then? Well, let's first ask ourselves, what is A and Q? So the value of A, which is the coefficient of x squared, essentially deals with how the shape of the parabola looks. Okay, so if A is positive, then we'll have a smiling parabola, right? Something like that. If A is negative, we'll have a sad parabola or a concave down parabola. Okay. And the other thing that it determines is basically how skinny or how wide the parabola is. Okay, so depending on that value, that this will move. Okay. And so that's A. And now what does Q represent? Q is the vertical shift. Okay, so let's say I have a axis here. Okay, the standard parabola, which is just x squared, will look something like this, right? So it'll have its turning point on the origin. Okay, and this is if A is positive. Now if I move that up, so let's say I make Q plus 2, it'll move up by 2 units. Okay, so it started there and it moved up. Let's say I make Q minus 5, it'll move down 5 units. Okay, so that basically determines the vertical shift. So in this case, we given the vertical shift because they gave us the value of the turning point. Okay, and remember we said already that our thing extends till 8. So that means that Q is equal to 8 because that is our vertical shift. Okay, so automatically we can say Q equals to 8. Okay, and let's see what A is equal to. Now how are we going to do this here? So let's start with this this equation that we're given. So we have G of x is equal to ax squared plus Q, and we said that Q is 8, so let's put that in already. Okay, now remember G of x is the same as saying y because that's the y value. Okay, so y is equal to ax squared plus 8. Now let's find a point on the graph. Alright, and we have 2 points that we can choose from. We can choose from S, we can choose from R. Let's take S. Okay, so the y value of S is 0 and the x value is 2. Okay, so you can see wherever I had y I put in 0 and wherever I had x I put in 2 plus 8. Okay, now I'll just manipulate this here and solve for a. So I'll bring this to the other side, make that minus 8. So minus 8 is equal to 4a because 2 squared is 4. Okay, so that means that a is equal to minus 2. Now think about this here. What did I say earlier about the shape of the graph, right? Does our answer make sense? Yes, it does, because we're saying that a is minus 2, and we can see that we do in fact have a down-facing parabola. Okay, so a is minus 2. Okay, and that's the right answer. Okay, determine the equation of f. So f is our straight line, right? We have mx plus c. Now let's break this down. So I'm gonna get rid of this for now. I'll keep my axis here. So we have y is equal to mx plus c. Now what do these things represent? So m represents the gradient. So what is gradient? So let's say I have a line, right? Let's say I start with a standard line that just goes through the origin, right? Now you can see that I can change the tilt of that line. Okay, so here it's less steep, here it's more steep, right? And that's basically our gradient. So the higher the gradient is, the more steep it is. The lower, the less steep it is. Okay, and if our gradient is positive, so in this case this would be a positive gradient, you can see that our graph increases that way. So as the x values increase, the y values increase as well. Okay, now let's turn that line around. Let's say I had a line going this way. This would be a negative gradient, because you can see that as the x values increase, the y values are decreasing. Okay, and again I can still play with the tilt. Okay, so this would be a higher gradient, this would be a lower gradient. Okay, so that's what m represents. Now what does c represent? Well, look, I can still have the same line here, but what if I took it and I moved it up a bit or down a bit? That's what c is. Okay, so let's say I started there and I moved it 2 units up, it would move there. Let's say I started there and moved it 2 units down, it would move down. So that would be plus 2 and minus 2, for example. Now in this case here again, so another way to think about it is the y-intercept. Okay, so it's where this line intersects the y axis. Okay, so in this case we again given it because it's the same point as the turning point of the parabola. It's at 0 and 8. So we can say that c is already given to us. It's plus 8. Okay, so now we have y equals to mx plus 8. Okay, now let's take a point on the graph. Now again we have 2 points. We have this T and we have R. Let's call it R. Okay, so I'm going to do the exact same procedure as earlier. Wherever I see y, I'm going to put in the y values for R. So it's 0. M is what we're solving for. We're looking for the gradient. And then I can put in minus 2 here because that's the x value, plus 8. And then I can get m. So again, I'll bring 8 to the other side. I'll get minus 8 divided by minus 2, which gives us 4. Okay, so that means that g of x is f of x, sorry. So f of x is equal to 4x plus 8. Okay, now again, let's see if these things make sense. We know that c has to be correct because that is the x-intercept. But what about our m value, our gradient? Well, I said earlier that if it's positive, it has to increase So we can see that our line is increasing. As the x values increase, the y values are increasing as well. So it makes sense that it's positive. Now you can take you can take that answer and put it down here. So okay, and that's correct as well. Use the graph to determine the values of x for which, okay? So where f of x is equal to g of x. So basically we're looking for, let me just gather some of this. We're looking for the points of intersection because they're saying wherever f of x is equal to g of x. And we can see that that happens at two places, at R and at T. So the x value at those places are, so x either has to equal to, remember we said this was minus 2 and 0. So x has to either equal to minus 2 or x has to equal to x has to equal to 0, right? So that's our two answers. Okay, now they want the values for which x times g of x is less than or equal to 0. Okay, that's quite a mouthful, so let's break it down, right? Let's first think about something quickly. Let's say I'm multiplying two numbers together. Let's say a and b. Okay, if I want to get a positive result, right, how many ways can I get that? Well, I can either have them both positive, so positive and positive will give us positive, or I can have them both negative, right? Negative and negative will give us positive as well. Okay, now let's say I want a times b to give me a negative answer. Well, again, there's two ways. I can either have a positive and b negative, that will give me a negative answer, or I can have a negative, b positive, and that will give me a negative answer as well. Okay, so let's keep this in mind and read the question again now. So let's ignore this first part for now. Let's just look at the sign. So less than or equal to 0. So that means that when we multiply these two things, we must either get something negative or something 0. Alright? Now, we spoke about this in a previous question, but how do you get something to be 0? So if I take a and b, and if I want it to equal to 0, then I either need them both to be 0, or I need one of them to be 0. Okay, so we're trying to look for a point where we get either something negative or something 0. So let's get rid of this middle part because we're not looking for anything positive. We're looking for either negative or 0. Okay, so let's see how we can get that. Now let's read the question again, this first part. So x times g of x. Okay, so let's think about our x values first. If you look at the x values are positive in this direction and negative in this direction and 0 here, right? So anything beyond this point is positive and anything beyond that point is negative, right? So that's our first number. And then our second one is g of x. So g of x is our parabola, right? And the parabola is positive from this point till that point. Let me highlight that. It's positive from here to here. Okay. And it's negative from this way downwards and from that way downwards. Okay. So let's see what the question is asking for again. When we multiply a and the value of g of x, we must get something either negative or something that equals to 0, right? So the obvious part where it's equal to 0, right, I'm going to get rid of this for now, is that, let's put this back in. At this point you're at r and at x, right? Obviously if I multiply that by the x values, I'm going to get 0. Because I can see that the value of the graph at that point is 0, right? And anything multiplied by 0 is 0. So we can let's start with this r point, right? Now if I keep moving in this direction and I go down, right, you can see that my x values are going to be negative, but my g of x values are going to be negative as well, right? So if I multiply that now, if I have x times g of x, I'm going to get something positive, which isn't what we want. We want something negative because less than 0, okay? So it's not going to work in that direction, right? Let's reconsider. So I'll get rid of this now. Now let's say we started at this point R and we moved in this direction, okay? So we moved up the graph that way, right? Now if we move in this direction, up until this point here, up until 0, let's say, my x values are still negative, right? Because remember, it's still beyond that point if I just move till there. And my y values, my g of x values are positive, right? So that works because if I multiply these two together now, if I say x times g of x, I'll get something negative, right? Because a positive times a negative is going to give me a negative. Okay, so let's do that then. Let's write that down now. So if I say -2, I'll explain what this means in a second. So x has to be greater than -2, okay, because it has to be greater than -2 moving in this direction, but it has to be less than 0, right? So essentially we're looking at this part of the graph here, okay? We're looking at that part of the graph, and we're looking at this part of the x-axis, right? And I said to you this part of the x-axis is negative, and this red part of the graph is positive, okay? So if I multiply the values at that point, remember we're looking for the point where x times g of x is less than or equal to 0. So if I multiply those 2 points, I will get, if I take a random point here, let's take this point here, right? I'll be multiplying a negative number, which is the x value, by a positive number, which is the y value of g of x, right? I will get something negative. And if I come down to the extreme here, I'll be multiplying 0 by 0 and I'll get something positive. I'll get 0, right? So that means that part works. Now let's consider the other side. So remember I said we can consider the two x intercepts, right? So let's look at this side now. Now again here, if I start at S and I move in this direction, right? My g of x values are going to be getting negative, while my x values are going to be getting positive. Okay, so let's think about that. I'm going to highlight this in red again. So here's this in red because we're looking at this part of the graph, and here's my x values, right? So I have positive x values and negative g of x values. So x times g of x, I'm going to get something negative, right? Because I took a positive x value and negative g of x values. That's going to give me something negative. So that means that works, right? So if I keep moving in this direction indefinitely, right? If I keep going this way, no matter how far I go, this is going to continue going down, and this is going to continue going positive. So that means that will keep working. So I can say that so this condition is true at this point, or when x is greater than or equal to 2, because there's our 2 there. Okay, so that's the two answers for that. So let's just write that down. So it was -2 or x is greater than or equal to 2. Okay, the next one, 5.6 now. The graph H is obtained when G is reflected along the line y equals 0. Write down the equation of G in the form h of x is equal to px squared plus k. So G is our parabola, right? And it's reflected along the line y equals 0. So firstly, what is the line y equals 0? Well, if we think about it, where is y equals 0? Y is only equal to 0 at the x-axis. Okay, so essentially this question is saying if the parabola is reflected on the x-axis, what will the new equation be? Okay, so what was our current equation? Our current equation was g of x is equal to minus 2x squared plus 8. Remember, we found it in this question here, right? So if I reflect this along the line, firstly, what's going to happen? Well, let's think about it. If I take this parabola, so now this turning point is going to move down there, and these points, so let's start with this point here, it's going to move up here. Okay, let me just move this, let me do this in a different color. Let's say with this blue, right? So this moved from there to there, and this point here moved up here, okay? And this turning point moved down here, okay? So I'm gonna erase the old lines now, so this, and this, right? And let's look at the new parabola that we have, okay? Now you can see that now we don't have a concave down parabola, we have a concave up. Okay, so essentially the only thing that changed is that instead of having minus 2x squared, we'll have 2x squared. And now we won't have plus 8, we'll have minus 8, because you can see that we moved down instead of moving up. Okay, so this is no more g of x, this is h of x. So h of x is equal to 2x squared minus 8. Okay. Okay, let's look at question 6 now, which is a continuation of functions, and here we're looking at an exponential function, right? So we told the function p of x equals to k to the power of x plus q is described by the following properties. K is greater than 0 and k is not equal to 1. The x-intercepts at 2 and 0. The horizontal asymptote is y equals to 9. Write down the range of p. Okay, so the range, firstly, remember we said is the y values. So if we look at p, let's firstly, okay, the horizontal asymptote. So an asymptote means that, let's say this is my asymptote and this is my function, right? An asymptote basically means that the function will approach that number, but it will never get to that, right? So here it's minus 9. So that means that the y values will get really close to minus 9, but they won't equal to minus 9. Okay, so y is greater than minus 9. Okay, not greater than or equal to, just greater than, because then it wouldn't be an asymptote. All right. Okay, the equation of p. Okay, so let's look at some basics here. This is a few exponential graphs that I drew. So if we look at the black graph first, right, this one here, you can see that we have all of them have the asymptotes at the x-axis, okay? And here we have a positive coefficient, a positive base, let's say rather, right? For the exponent, for the exponential graph, right? And that gives us the graph extending that way. Okay, now let's take that same graph with the same base, but we make x negative. So let's look at the blue graph now. We can see it extends towards the negative x values. Okay. Now if we take these two upper graphs and we make the coefficient negative, right? So you can see I made the coefficients negative. It literally just takes the graph and reflects it on that there. So you can see this, the green graph came from the black graph. It just took the negative there. And then the red graph came from the blue one. It just became negative, but it's still negative x as in the blue. Okay. So if we look at what the conditions we given, k is basically our base, and we told that it's greater than 0. Okay, so k is positive. So we can completely forget about these two. Okay, so our graph of p can only look like one of these. Okay, and we can see x is positive as well. That means we can forget about this one now. So it can only be the black graph. So we're going to keep that in mind now as we look at the next questions. But before we get to that, let's get the equation of p. Okay, so we have p of x okay. Now what does q represent? Q represents the shift. Okay, so let's say I took this black graph and I moved it up by 2 units. Okay, so now this will become 2x to the power of 2 plus 2. Okay, I moved it up by 2 units, and the asymptote would move from 0, because remember here it is at y equals to 0, which is the x-axis, it would move to y equals to 2. Okay, so in this case we told the horizontal asymptote is minus 9. So that means our q, we can say, is minus 9 as well. Okay, so now basically the only unknown that we have is k, because this and this is going to come from whichever point we use, and we have a point, we have this point here, 2 and 0. So let's insert that in there. So at the y value we're putting in 0, and at the x value we're putting in 2. Okay, we can now solve for k. Now if you look at this, k can either be positive or negative, right? Think about this. If we square root a number, let's take 9 for example, I can get to 9 by either saying minus 3 times minus 3 equals 9, or by saying 3 times 3 equals 9. That's why it's very important when you find the square root of these things to show that it can be positive or negative. Okay, but now we have to actually choose an answer. But based on what we're given, we know that k is positive, so k has to equal to 3. Okay, so now that's all the components of our formula. So we have p of x equals to 3x minus 9. Okay, now that's to 6.1.3. Okay, sketch the graph of p, show clearly the intercepts with the axes and the asymptote. Okay, so first let's draw in the asymptote. Here I drew it in already at y equals to minus 9. Okay, so the graph is going to go upwards that way, and it's not going to touch minus 9. Okay, and we already decided why it's going in that direction. Okay, now we were given the x-intercept. Okay, so all I did was just put it in there. Now to get the y-intercept, what you have to do is, remember at the y-intercept, x equals 0. Okay, so it's on the y-axis. So I just took 0, I inserted it there. So now we have 3 to the power of 0 minus 9. You put that into the calculator and you'll get minus 8. Okay, so then that's your y-intercept. So that's that question done. Let's move on to question 6.2. So this here looks like at hyperbolas. So the sketch below shows the graph of f of x equals to k over x plus w, and g equals to minus x minus 1. The graph g is an axis of symmetry of f. So f is the hyperbola. Okay, and g is the axis of symmetry of that. Okay, the graphs f and g intersect at p and at q. Write down the value of w. Okay, so firstly w is here. So you can think about for hyperbolas, right? Let's start with the standard form. It's going to look something like this. X minus p plus q. Okay, this one doesn't have a horizontal shift, so let's forget about this for now. Okay, but this q is going to show us the horizontal asymptote. Okay, so if you think about how hyperbolic graphs look, they look something like this, right? Okay, so you can see that there's and this will carry on, but it won't touch whatever the asymptote is. So let's just assume the asymptote in this example is the axes. Okay, so the graph won't touch these axes. Okay, and what that means is that the asymptote will be y x equals to 0 and y equals to 0. Okay, that's our two asymptotes. So what q represents is the y in the y asymptote or the horizontal asymptote. Okay, so in this case it will be 0 in the example, but in this case it's not equal to 0. It's actually equal to minus 1, and I'll explain why. It's because we were told that this here g of x, this line, is an axis of symmetry, right? And the way the axis of symmetry works is that it'll intersect the point where the two asymptotes intersect. Okay, so if we go back to our example, if I throw in an axis of symmetry here, that axis of symmetry would have to go through the origin, because here at 0 and 0 is where our two asymptotes intersect, right? By definition, the origin is where the two axes intersect, right? So if we look here, we know that there isn't a horizontal shift, right? So that means that our is still at 0, right? So, but we know that it moved down by 1 or by some number because we have a shift on that graph. So that means this point here is 0 and minus 1. Okay, so that's how we can conclude that that's at minus 1. Now you might ask, why didn't I assume that this is the point of intersection? And the reason is because we know that there isn't a horizontal shift. So there isn't a shift in this way or that way. So this has to be at 0. But there is a vertical shift. So it moved down by 1. Okay. Okay. The point minus 2 and minus 7, minus 2 and 7, so that there lies on F. Calculate the value of K. Okay, that's a straightforward one. So we have y equals to k over x plus w, which we determined was minus 1, right? And we have a point minus 2 and 7. So 7 equals to k over minus 2 minus 1. Okay. Now I'm just going to solve algebraically and I'll get k as minus 16. Okay. And the way I did that was just bring that over there to get 8, and then 8 times minus 2 is minus 16. Okay, cool. Calculate x coordinates of P and of Q. Okay, so if you look at P and Q, that's the point where G and F intersect. Okay, so 6.3.3, oh, 6.2.3, sorry. 6.2.3. So G of x equals to F of x. So we have to find the point where that's true. Okay, so G of x is minus x minus 1, so minus x minus 1, and F of x is minus 16 over x, because remember we calculated what k is, minus 1. Okay, right. Now if I bring this minus 1 to this side, I'm just going to get 0, right? Because minus 1 plus 1 is 0. So I can just immediately get rid of this. Okay, and now you'll see that I can have this, so I can multiply this x to get rid of the denominator. Okay, so I'll have minus x squared equals minus 16. Now I have minuses on both sides, so I can get rid of that. and then therefore x is plus or minus 4. Okay. Now, if you look, this is what I was saying earlier as well. Remember, I can have it as 4 times 4 to get 16, or minus 4 to get 16 as well. Okay. Now, if you look at where P and Q are, right? P lies this side of the origin, Q lies that side. So this side is negative, this side is positive. So P has to have the negative value. So I can say that x of P equals to minus 4 and x of Q is positive 4. Okay. Write down the values of x for which minus 16 over x is greater than minus x. Okay, so minus 16 over x is greater than minus x. Okay, so remember, this is literally the exact, if you look at it nicely, you'll see that if I take this expression here that we had earlier, right, I have minus x and I have minus 16 over x. Remember, this happened after we took away those minus ones, right? And I have this greater than sign in between them, right? This is this expression. Now, if you look at this, right, remember, let's say I have this equation a equals to a, right? This is true. A equals to a, that's obvious, right? Now, let's say I added b to this side, right? How would I make this equivalent again? I can add b to that side as well, right? So how can I make these two sides, well, I can make them have the same value still if I subtract 1 on that side and if I subtract 1 on that side, right? See, they'll still hold the same value. It'll be the same as me saying it like that, right? So if I look at this now, minus x minus 1, that's the same as saying g of x, okay? G of x. And minus 16 over x minus 1 is the same as saying f of x, okay? So essentially what the question is asking is, what are the values of x for where f of x is greater than g of x? Okay, so let's see where that's true. So f of x is the hyperbola. So it's greater than g of x at the following places. I'm just going to get rid of these things. But it's greater from here. Okay. And it's greater from here. Okay. But now remember, it's not going to continue indefinitely from here, right? Because it's going to come up against its asymptote. It can't move past the y-axis. Okay. So this point here was minus 4 and this point here was plus 4. Okay. So we can say that x has to be greater than minus 4 but less than 0. Okay, so that will restrict it to before the asymptote. Okay, does that make sense? And then on this side, you can see it will continue indefinitely being greater than the straight line. So on this side, it's much simpler. We can just say that x has to be greater than 4. Okay, so let's write those two down and then we'll have the answer. So this condition is true when x is greater than 4 or when x is greater than minus 4 but less than 0. Okay, so that's question 6 done as well. Okay, we're now going to look at question 7. So this is a probability question. Two events A and B are complementary. So what does it mean for two events to be complementary? It means that if event A happens, then event B can't happen. Okay, and likewise, if event B happens, then event A can't happen. Okay, so complementary and make up the entire sample size. Okay, also P not A. So if you see a probability with that little apostrophe, that means it's not A. Okay, so the probability of not A is 0.35. Okay, 7.1.1, complete the statement. The probability of A plus the probability of B equals to 1. And that's because, like I said, if you're doing A, you can't do B. If you're doing B, you can't do A. But they also say that it makes up the entire sample size. So that means you only have two options. So if you're doing A, you have to do A, you can't do B, and if you're doing B, you have to do B and not A. And there's no other options. So that means that if you add the probabilities up, it's equal to 1. Okay, write down the value of the probability of getting A and B. So that's obviously 0, because like I said, you can only do one or the other. Okay, write down the probability, the value of PB. So we have the probability of not A. Okay, so if you're not doing A, you have to be doing B. So that just means that it's the same, right? So the probability of not A is the same as the probability of B. Okay, cool. So that was pretty easy. Let's go on to 7.2. A survey was conducted among 150 learners in grade 10 at a certain school to establish how many of them owned the following devices: smartphone or tablet. The results were as follows. 8 learners did not own either, 20 learners owned both, 48 owned a tablet, and X owned a smartphone. Represent the information above in a Venn diagram. Okay, so let's draw ourselves a Venn diagram. Okay, so we'll start with our rectangle to contain everything. And now remember, we have two options. Basically, it's for smartphone and for tablet. So I'll draw two circles. Okay, so let's start here. Our total amounts, our total sample is 150. So we say S is 150. Okay, 8 learners did not own either. So 8 is outside of the two circles. Okay, 20 owned both. So 20 can go there. And let's call this here smartphone. Let's call this tablet. Okay. 48 owned a tablet. Okay, so this entire circle here represents the tablet. Okay, so 20 is already accounted for there, so the remainder is 28. Okay, oops, 20. Okay, and then for the X learners owned a smartphone. Okay, so that's going to be X minus 20. Okay, why do I say that? Because remember, this whole circle has to equal to X, and if we already accounted for 20 in the intersection here, then the rest is X minus 20. Okay, fine. How many learners, let's look at the next question now. How many learners owned only a smartphone? Okay, so that's that X minus 20 figure. Okay, so if you think about this now, let's just put this in. This is 7.2.1, 7.2.2 now. If you think about this, we have 150 people in total. So everything that we add up must come back to 150, sorry. So we first have the 8 that don't own either. Then we have this 28 that own only a tablet. Then we have 20 who own both. And then we have X minus 20 who own only a smartphone. Okay, and now you can see we have one unknown, so it's pretty simple. We just take all of these to the other side and subtract it, and the 20 as well, but that's going to become positive 20, and then we can solve for X. So I'll just punch all this into a calculator. So 150 minus 8 minus 28 minus 20 plus 20. that gives us 114. Okay, so X is 114, right? X. But the number of people who owned only a smartphone is X minus 20. Okay, so therefore number of students with only a smartphone is equal to 114 minus 20, which is 94. Okay. Now let's see what 7.2.3 says. It says calculate the probability that a learner selected at random from this group owned only a smartphone. So we already calculated. Okay, so let's see. Probability of only smartphone is the number of smartphones over the total, right? So let's say total. So that's equal to 94 over 150. Okay, so you can just punch that into your calculator and see what you get. I get 0.63. Okay, the next one says calculate the probability that a learner selected random from this group owned at most one type of device. Okay, at most one type of device. So that means that you need okay, so at most one type of device means that if you think about it, right, you have a few options here. You can either own 0 devices, right, and that's none. You can own one device, so that's either a smartphone. You can own one device, and that's either a tablet. You can own two devices, and that's a smartphone and a tablet, right? So they're asking for at most one. So that means you must account for all of these possibilities except this one here, okay? Because that's two devices, but they're saying the max at one, okay? So that means we have to find the probability or the total or the probability of owning these individuals and then add it together. Okay, so the probability of at least or at most one device is equal to the probability of a smartphone only plus the probability of a tablet only plus the probability of none, right? So that's 94 over 150 plus 48, and remember 20 plus 28, so 48. Oh no, sorry, not 48, 28, because we want only at 1, right? Because this would be 2, so it's only 28 on 1 only, so it's 28 over 150 plus, and then the probability of none is 8. Okay, so that's 8 over 150. Now if you add that all up, put it in your calculator, you should get 0.86 or 0.87. Okay, so that's the whole paper done. If you have any questions, you can leave them below and I'll see if I can get to them. And if something is unclear, you can also ask that down there. Thank you.